Hello, everyone. Today we're going to go through IXL Assignment DRB, Identify Equivalent Linear Expressions. First, let's talk about some vocab, because I just used a lot of math vocabulary words, even in the name of that IXL assignment. The first one is expressions. If we look at this bottom bracket here, this entire thing, so the 5x squared plus 2, that is called an expression, because there is no equal sign, no inequality sign. Therefore, it is simply an expression. Then within that expression, if we get a little bit smaller, we have two terms, and our terms are separated by either plus or minus signs. So right here, this 5x squared, that is all together, that is one term. And then your 3 is a second term. If we look at our first one here, I'm actually going to start with the blue. So that letter X, when we use letters in math, those are called variables because that represents something that is unknown. If you have a number that is right in front of your variable, so in this case, it's a 5, that is being multiplied by your variable, and its special name is the coefficient. All right, so these two words are really important, and you'll see why in a moment, that your coefficient is the number with your variable, and that variable is the letter. Another vocab word, this one you probably have seen before, just maybe not on a variable, is this green 2. When we have that superscript up there of a number, that is an exponent. And last but not least, this 3, when you have a plain number that is all by itself, that is considered a constant because it doesn't have a variable that it's being multiplied by to change its value. That term, that 3, is a constant. It is 3, and that's what it represents. Okay. The two topics, the two skills that you're going to need to do this IXL assignment are being able to combine like terms and use the distributive property. So first, let's talk about combining like terms. We just mentioned what a term was. All right, that is when you have a set of something and all the terms are separated by plus or minus signs. In order for them to be alike, in order for you to be able to combine them, so either add or subtract them, they have to have the same variable and have the same exponent. And the way we combine those is like terms are combined by you add or subtract the coefficient. So there's lots of examples here, but we're just going to look at a couple. So this first one right here, 2x plus 4x, those are like terms because they both have the variable x. So because they're alike, because they're the same, I can combine them, I can add them. And I just simply add the coefficient, so the number that's with it. 2 plus 4 is 6, so 6x is our like term. If we look at this second one here, it also works for subtraction. So 7b and 3b are like terms because they both have the same variable. So because they're like terms, because they have that same variable, I can combine them. And in this case, we're being instructed to combine them through subtraction. So you just subtract the coefficients. 7 minus 3 is 4. Now, sometimes we have to use the distributive property. That distributive property often comes into play because of like terms, or more specifically, because of having unlike terms. We're going to come to the bottom here and look at our examples. So if we look at this first example, we have the expression 5 times the quantity of 2x minus 7. Well, if we're asked to simplify that or find an equivalent expression, we think back to the order of operations that always tells us what to do first. Well, what we need to do first are parentheses. However, when we look inside those parentheses, we can't actually take 2x minus 7. Why can't we subtract them? Because they're not like terms. The 2 has an x, the 7 doesn't. We have a variable term and a constant. So they're not like terms. I cannot subtract them. That is where the distributive property comes into play. The distributive property is kind of like a loophole. It's a workaround. It allows us to get rid of those parentheses when you can't combine like terms. So this 5 is being multiplied by everything inside the parentheses. We're going to multiply 5 times 2x, and then we also multiply 5 times 7. 5 times 2x, you multiply your coefficients, 5 times 2 is 10, the x stays with it, 10x. You bring that subtraction sign down, 5 times 7 is 35. And this right here would be your final answer because we have no more distributive property and we have no more like terms. So 10x minus 35, we are good to go. All right, a few examples that we did here. Now let's switch over to IXL because that is the best part because you can actually see me work it out and see some examples exactly like you are going to have. All right, here we are on IXL. Just a quick reminder that even though there are multiple ways to find your assignment, my favorite way is when you're in OMHS and it gives you the name of the assignment, it starts off with a little code that is 3 numbers or letters long. That is its skill ID. If you type that right here, in this case, it's DRB, it'll come up with a lot of options, but you always want that first one that the name matches, it says match skill ID, and has the right grade. Then when you click on it, a way to kind of confirm and know that you're on the right one, not only does the name match what you see in OMHS, but it also has a gold star. That means I or one of your other teachers have assigned it to you, so you need to make sure to do it. Okay, now that we've discussed that, let's hop to it. So our first question is we want to know which expression is equivalent. So equivalent means equal to 3 times 3j. Because remember, parentheses are one way to show multiplication. Well, in this case, it's like a mini distributive property. We're distributing, we just only have to distribute to one thing. So 3 times 3j, we just multiply our coefficients. You can just work on those numbers. 3 times 3 is 9. So 9j would be our equivalent expression. All right, let's try this one. Which expression is equivalent to 2g plus g? Ooh, this is a good one. So first thing is we need to make sure that these are like terms. Are they like terms? Yes, and I know that they're like terms because they both have a g with them. Now that we've established they're like terms, we can just add our coefficients. So in this first case, my coefficient is a 2. I have 2 g's. But if we look at this one, what's that coefficient? I don't see anything there. It's not 0 because there is a g there. How many g's are there? 1. So whenever you have a variable by itself, there is technically a coefficient of a 1 because there is one of them there. We can now add those coefficients. 2 plus 1 is 3, and our g, our variable, stays with it. Be careful when you look at your answer choices not to rush and make sure you always pick the one that does match your answer. How about this one? 3u plus 5u. Are they like terms? Yes, they are, because they both have the same variable. We can just do what it says. In this case, it's telling us to add 3 plus 5 would be 8. 8u is our answer. All right, let's jump up a level, try to find another one. Here we go. We got the distributive property here. We have 3 times the quantity of a plus 4. You'll hopefully get into the habit of where you, just like I did, can quickly see it's the distributive property. If you're not there yet, no big deal. But we know that we need to find an equivalent expression. So we're going to simplify. Order of operations tells us to do parentheses first. But when we look at our parentheses here, I have a plus 4. Can I do a plus 4? No, because they're not like terms. Our a is a variable, our 4 is a constant. Therefore, our workaround is to do the distributive property. That will clear out our parentheses. And we are going to multiply that 3 by everything inside the parentheses, because parentheses are one of the ways, they do mean multiplications. They're one of the ways we can show that. So that really means 3 times the a plus 4. First, we're going to multiply 3 times a. That would just be 3a. Then we're going to bring our plus sign down and multiply 3 times 4, because you have to multiply it by everything. 3 times 4 is 12. Can we do anything else? Hopefully you said no, because these are not like terms. The 3 has the variable a, the 12 does not. So because they're not like terms, that is simplified. That is all we can do. And looky there, we do have an answer that matches. This is a good one. Not only do we have some extra steps, we do have negatives. That right there is the one thing that I think will be trickiest, is making sure you're careful with your negatives and you don't accidentally mix them up, okay? Let's write our problem out. -2 times -2s plus 1 minus 3s. All right, when I look at this, I got a lot more going on, but I'm going to come back to order of operations. Order of operations, a lot of times you hear PEMDAS or maybe GIMDAS, but first we need to deal with that grouping symbol. We need to deal with our parentheses. When I look at the parentheses though, I can't simplify what's inside of them. The -2s and the 1 are not like terms, so I can't combine them. That brings us to the distributive property. The distributive property is what we're going to use to do that parenthesis step. Let's multiply -2 times -2s. When multiplying and dividing integers, so multiplying and dividing negative and positive numbers, if their signs are the same, your answer will always be positive. If their signs are different, your answer will be negative. So a -2 times a -2s, they have the same sign, which means a positive answer, positive 4s. But then when I go and multiply -2 times a plus 1, they have different signs, -2, positive 1. So when you're multiplying or dividing and they have different signs, your answer will always be negative. This -3s is outside of the parentheses, so I don't distribute it, but I do need to bring it down because it is still part of the problem. When we think about order of operations, we just dealt with our parentheses. Do we have any exponents? Nope. Do we have any multiplication or division that we can do? Nope. So last but not least, that brings us to adding or subtracting. In order to add or subtract, we need to hunt for like terms. Are there any like terms we can combine? Yes, sirree, there are. I have a 4s, and then you always include the sign with it, a -3s. By including that sign, that tells us that we are subtracting these like terms because it's a -3s. 4s minus 3s would be 1s. Does your -2 here have a like term? Nope, there's no other constants, so we just bring it down. Even though this right here is the correct answer, I don't have a perfect match. If we think back to a couple problems ago, whenever we have a variable and there's only one of them, the proper way to write it is to just write the variable, to not include the 1. So technically our answer would be s minus 2. As mathematicians, we like to be a little bit lazy. Whenever we can make a shortcut, we will do so, and that's one of them. If you have a variable all by itself, there's only one of them, we don't write the 1. We just write the variable. All right, this one's pretty similar. Let's see if we can find one that's a little bit different. Ah, here we go. This is a good one. Let's try this one out. 2 times the quantity of 3d plus 5 plus 2. All right. So with this, we need to find an equivalent expression. We need to simplify. Order of operations tells us to deal with our grouping symbols first. In this case, my grouping symbol is parentheses. But can I do what's inside the parentheses? I hope you said no. And why can you not take 3d plus 5? Because they're not like terms. The 3 has a d, the 5 does not. So that workaround, the way we can get rid of those parentheses is using the distributive property. We're going to distribute that 2 to everything inside the parentheses. So 2 times 3d, 2 times 3 is 6, 6d. 2 times 5 is 10, and don't forget to bring down your plus sign. Do we multiply the 2 by this positive 2? I hope you said no, and the reason why is because that plus 2 is outside of the parentheses, so it's not included in that group. But it's still a part of the problem, so we just bring it straight down and we show our work. All right, keep going through order of operations. I don't have any exponents. There's no multiplication or division that can be done, which brings us to addition or subtraction. In order to add or subtract, they have to be like terms. Do we have any sets of like terms here? The 10 and the 2. Does our 6d have a like term? No, there's nothing else that has the variable of a d. So that 6d has no like terms. We're just going to bring it down. It's still part of our answer. But then our constants, so our plain numbers, are considered like terms. And we always just do what it says. 10 plus 2, which would be 12. And looky there, it matches. Yay! All right, this will be our final problem that we do together. What do we do when we get, higher into the SMART scores and it gets not necessarily more complicated because it's the same steps, but it looks a little bit more complicated because there is a little bit more work involved. So you'll have to use a bit more of your paper when you're writing out your problem. But I know you guys can do it. All right, first we'll copy the problem down. 2 times the quantity of 6m plus 1 plus 2 times the quantity of 2m plus 5. Ooh, I'm almost running out of room. Oh no. All right, even though this problem has a lot more going on, it looks a little scary, let's always go back to that order of operations. And that tells us to do the grouping symbols. So the parentheses first. Well, I have 2 sets of parentheses. We're going to need to do both of them. Can you actually add anything inside either of the parentheses? Nope. And our first one, the 6m and the 1 are not like terms. And our second one, the 2m and the 5 are not like terms. So we're going to distribute in both cases. We're going to deal with them separately though. So our first one, we are distributing 2 to the 6m. Remember, to distribute, that operation is multiplication. 2 times 6m would be 12m. And then 2 times 1 would be 2. Always bring your signs down. From our original problem, I'm going to bring this plus sign down, and now I have a second set of distribution to do. Over here, we're going to distribute 2 times 2m, which would be 4m, and then 2 times 5, which would be 10. All right, that wasn't too bad, right? We just had to do the distributive property twice, but that was okay. Move on to the next step. We need to work with any exponents. Nope. Any multiplication or division that I can do? Nope. So last but not least, addition and subtraction. we better find those like terms. If you struggle finding your like terms, you can highlight them, circle them, underline them. But what I do is I just kind of start at the left because that's the way I read and see if there's anything that matches with it. So I'm going to circle this 12M. Are there any other terms that have an M? Yes, there is. Always include the sign before it because that tells you whether you're adding or subtracting. So 12M plus 4M. We're adding 16M. Now I have this positive 2. Are there any like terms, any other constants? Yes, there is. Again, circle the sign that goes with it because that tells you whether you're adding or subtracting. We have 2 plus 10, which would be 12. Can I simplify it further? Nope, because I don't have any more like terms. So there we go. All right, guys, it is now your turn to try it. Please make sure that you work out all the steps like I did and really be careful with your positives and your negatives, because that's where I think the most mistakes might happen. So if you need to refer back to that integer chart from last semester, I have reposted it, so you can always check that out as well. All right. So good luck. If you need anything, come to a help session next week, or of course, send an email and your teacher will be more than happy to assist. Bye.